Did you know that companies like X, GitHub, Pinterest, and Snapchat all rely on Redis to handle massive amount of data at the speed of light? It's incredible. Redis can perform more than 100,000 operations per second. That's way faster than you can blink. Hey everyone! Today we'll dive into Redis, one of my fav. If you've ever wondered, is Redis a database, cache, or message broker? The answer is yes. It's all that and more. Redis is a fast, in-memory key value store used by huge apps like X, GitHub, and Stack Overflow. Instead of saving data to disk, Redis keeps it in memory, making it lightning fast. It's like looking up info on your desk versus walking to the library. What makes Redis special is not just speed. It is its versatility. I've used it for everything from session management to leaderboards and rate limiting. Quite a simple concept, a giant dictionary in memory where you give it a key and it gives you a value. In this video, I'll explain how Redis works, why it's so popular, and why it's perfect for microservices. Whether you are a developer or just curious, this video will give you a solid understanding of Redis without overwhelming you. Let's get started. Redis stands for Remote Dictionary Server, and it's a fast, lightweight, in-memory data store. At its core, Redis is a key value store that keeps data in RAM for super fast access, making it vastly quicker than traditional disk-based storage. So why exactly has Redis become so insanely popular? Well, according to database engines ranking, Redis consistently ranks in the top 10 databases worldwide and is the number one key value store by a wide margin. That's pretty impressive for a project that started as a one-man effort by Salvatore Sanfilippo back in 2009. The first and most obvious reason for its popularity is speed. Redis operates in memory, making it orders of magnitude faster than traditional disk-based databases. For instance, Redis reduces page load times in apps by caching frequently accessed data, offloading work from the main database. Another huge factor in Redis' popularity is its simplicity. The Redis command set is intuitive and easy to learn. Want to store a value? Use set. Want to retrieve it? Use get. Want to check if a key exists? Use exists. The commands making it easy to learn compared to other databases. Redis also offers versatility through its data structures. It supports various data types, allowing for complex data relationships and fast, efficient queries. For example, sorted sets can be used for real-time leaderboards, providing instant rankings without complex queries. Redis offers built-in persistence options. While primarily in memory, Redis offers durability by saving data to disk at intervals or after a number of writes, balancing performance and data safety. Another killer feature that's made Redis popular is its built-in pub/sub messaging capabilities. This allows Redis to act as a lightweight message broker between different parts of an application. For instance, in a system that requires real-time notifications, one component can publish a message when an important event occurs, and other components subscribed to that channel can immediately react, whether it's updating a user interface, triggering a workflow, or logging the event. Redis is also extremely reliable. It's been tested in production environments at massive scale. The Redis Sentinel system provides high availability through automatic failover, and Redis cluster allows you to distribute your data across multiple nodes for both performance and reliability. Finally, Redis has gained popularity because it fits perfectly to modern architectural patterns, especially microservices. Each microservice can have its own Redis instance or share a Redis cluster, which enables them to cache data, communicate via pub/sub, implement rate limiting, or manage distributed logs. I've worked with various databases through my career, and I've never seen one that hits the sweet spot of performance, simplicity, and flexibility quite like Redis. Let's peek under the hood of Redis and understand its architecture, without getting too deep into technical jargon. Redis has a surprisingly simple yet powerful design, which contributes to its incredible performance. The heart of Redis is its single-threaded architecture. Wait, single-threaded? In a world where everything seems to be going multi-core, multi-threaded, and multi-everything, Redis takes a different approach. By being single-threaded, Redis avoids complex locking and thread coordination issues that can slow down multi-threaded systems. When I first learned this about Redis, I didn't take it serious. How can something single-threaded be so fast? But then I discovered that Redis uses an event loop model similar to Node.js, which allows it to handle multiple connections concurrently without the overhead of thread management. It uses an I/O multiplexing technique that efficiently manages thousands of connections and doesn't create any thread for each one. According to Redis creator Salvatore, this single-threaded design was a deliberate choice to keep the core simple and bug-free. And the numbers don't lie. Redis can handle over 100,000 operations per second on a modest server. I've personally used Redis to handle peak loads during Black Friday sales events without breaking a sweat. At its foundation, Redis stores everything in memory. This is fundamental to understanding how Redis achieves its speed. When data is stored in RAM, access times are measured in nanoseconds rather than the milliseconds required for disk access. Redis organizes data using various data structures, and this is where it gets really interesting. Unlike simple key value stores that only let you associate a string key with a string value, Redis supports multiple data types. Strings, the most basic type, which can be text or binary data up to 512 megabytes in size. Lists, linked lists of strings, perfect for things like timelines or message queues. Sets, an ordered collection of unique strings, great for tracking unique visitors. Sorted sets, similar to sets but each element has a score for ordering, ideal for leaderboards. Hashes, maps between string fields and string values, perfect for representing objects. Bitmaps, allow bit level operations, great for efficient storage of Boolean information. Hyperlog logs, probabilistic data structure for estimating unique elements in a set. Streams, a newer data type for append-only collections of map-like entries. These data structures aren't just storage formats. They come with specialized commands that operate directly on the data. This is a huge advantage. For instance, with a sorted set, you can add an element with its score and retrieve the top n elements, all with simple atomic operations. In a commerce inventory system, Redis hashes can be used to efficiently track thousands of products and their stock levels. Each product can be represented a hash with fields like name, price, quantity. When stock levels need to be updated, such as after a purchase, atomic hash increment by command can adjust the quantity, ensuring data consistency without the risk of race conditions. Another key architectural feature is command processing pipeline. When a client sends a command, Redis follows these steps. Read the client's request, parse the command, execute the command. This is where the magic happens. Format the response, send the response back to the client. This process happens incredibly quickly because everything is in memory and the command implementations are highly optimized. Most commands in Redis have O1 or O log n time complexity, which is computer science, speak for really fast even with lots of data. Redis also includes persistence mechanisms to ensure your data survives server restarts. It offers two main approaches. RDB, Redis database, point-in-time snapshot of your dataset at specified intervals. AOF, append-only file, logs every write operation, which can be replayed to reconstruct the dataset. You can use either or both together depending on your durability needs. In production systems, I typically use both AOF for minute by minute durability and RDB for efficient backups. For scalability, Redis offers several built-in features. Redis Sentinel enables high availability through monitoring, notifications, and automatic failover. Redis Cluster allows data to be automatically sharded across multiple nodes for horizontal scaling. For instance, in systems handling terabytes of data spread across dozens of nodes, Redis cluster has been used to ensure stability and performance. Once properly configured, it can efficiently distribute load and maintain availability even under heavy traffic. Under the hood, Redis uses an in-memory hash table to store keys and pointers to their values. This hash table implementation is extremely efficient, allowing for all 9 lookups regardless of how many keys you have. Redis also employs techniques like incremental rehashing to ensure operations remains fast even when the hash table needs to grow. One of the most fascinating aspects of Redis architecture is its eviction policies. Since memory is finite, Redis provides configurable policies for what happens when memory fills up. You can choose to no eviction, return errors when memory is full, LRU, evict list recently used keys, LFU, evict list frequently used keys, evict random keys, and several other variations. This gives you fine-grained control over how Redis behaves under memory pressure. I'll bring an example. Once I was working on a caching system where we specifically wanted newer cache entries to take precedence over older ones, and Redis max memory policy setting made this trivial to implement. Redis architecture is a beautiful example of how sometimes the simplest design can be the most powerful. Redis is incredibly versatile, and knowing when to use it can give your applications a significant performance boost. Let's explore some of the most common and effective use cases I've encountered in my years of working with Redis. Caching is probably the most popular use case for Redis, and for good reason. For example, on a high traffic news website, Redis caches homepage content for a short time, reducing database load and improving page load times from seconds to milliseconds. The great thing about Redis as a cache is its flexibility. You can cache individual objects, full page outputs, or even fragments of pages. You can set time to live values on each key, ensuring that data is automatically refreshed when needed. The combination of speed and automatic expiration makes Redis perfect for this role. Session storage is another area where Redis nails it. When applications need to track user sessions, and storing this data in Redis offers several advantages. For instance, during peak shopping seasons on e-commerce platform, Redis handles sessions efficiently, improved performance and simplified horizontal scaling. Leaderboards and counting are use cases that showcase the power of Redis sorted sets. Whether you are building a gaming application, tracking social media metrics, or managing any kind of ranking system, Redis sorted sets make this incredibly efficient. Redis simplifies rate limiting for APIs. For example, a service used Redis to limit client requests to 100 per minute, protecting it from overuse and malicious attacks. Queues and job management is another area where Redis excels. Using Redis lists, you can create simple but effective job queues for background processing. Add jobs to one end of the list and have workers pick them up from the other end. Real-time messaging is made possible by Redis PubSub capabilities. This pattern allows different components of your system to communicate in real time without tight coupling. A collaborative editing tool was built using Redis PubSub similar to Google Docs. When one user made change to a document, their client would publish those changes to a Redis channel. Other users working on the same document were subscribed to that channel and would receive updates in real time. The entire real time communication infrastructure was powered by just a few Redis commands. Distributed locking is important in microservices architectures where multiple services might need to access a shared resource. Redis provides atomic operations that make implementing distributed locks reliable. For example, once we used in a ticketing system to prevent multiple users from selecting the same seat simultaneously. These use cases just scratch the surface of what's possible with Redis. The key is understanding Redis strengths, speed, atomic operations, versatile data structures, and operational simplicity, and applying them to your specific challenges. One last thing to note: Redis isn't meant to replace your primary database in most cases. It works best alongside traditional databases, each playing to their strengths. Redis handles high speed, transient, or frequently accessed data, while your primary database manages the persistent storage of your application's information. This was the whole story with Redis. We have explored its speed, architecture, and various use cases that can supercharge your applications. What I hope you take away from this video is that Redis isn't just another database. It's a problem solving tool that can address many of the most common performance and scalability challenges in software development. Redis offers elegant solutions that are both powerful and easy to implement, and it doesn't depend if you are looking to speed up database access with caching, to implement real time features with PubSub, to build leaderboards with sorted sets, or to manage distributed state across microservices. I'd love to hear about your Redis experiences. What challenges has it helped you solve? Or if you are new, what questions do you have? Let's chat in the comments below. If you found this explanation helpful, please hit that like button and subscribe to the channel for more tech explanations. Don't forget to hit the bell icon so you never miss a new video. Thanks for watching, and I'll see you in the next video.